Hello students. Uh, the next chapter is distribution and network models. So here we are going to use LPP to construct models and then solve them to get the optimum solution. Some of the applications are transportation problem, assignment problem, transshipment problem, shortest route problem, maximal flow problem, and even production and inventory application problem. So in this video, we are going to look at the transportation problem. So transportation problem, it goes like this: that there are plants which are producing the material, and there are distribution centers which receive the material produced from the plant through various transportation routes. So plants are our origin, and distribution centers are our destinations. And plants have capacity, so here they are considering 3 month production capacity. So for example, Cleveland plant has 5,000 units capacity, Bedford has 6,000, York plant has 2,500, total 13,500 is our production capacity. On the other hand, distribution center requirements are given here, or demand forecast. Boston will require 6,000 units. Chicago distribution center will require 4,000 units in these 3 months, and so on. Right. So here the total production capacity and total distribution demand, or demand at the distribution centers, is matching. And then there are routes. So these are the, I will come to this diagram later on. So you have this transportation routes from Cleveland to Boston. The transportation will cost us $3. So if you see here, the cost is given here per unit, right? And the from Bedford to Chicago it is 5 units. From York to St. Louis is 4 units, $4 per unit, right? So this is the information. So if you want to show this on a single diagram, all the information, it can be shown like this, right? So this is where the entire information is shown here. So you have your origin plants here on the left side with their production capacities, which are called as supplies. On the right side you have the 4 distribution centers, and their demands are given here: 6,000, 4,000, 2,000, 1,500 demands, and connecting them. So currently from all the plants to all the distribution centers, the road network is available, but it will be obviously at different per unit cost because the distance will differ. So if you see from Cleveland to Boston, we can transport at a rate of $3 per unit. From Cleveland to Chicago, $2 per unit. From Cleveland to Lexington, it will be $6 per unit. So like this, the information, all the information is captured here on this diagram also. So the variables, so to set up the problem, we have to first define the variables. So let xij be the number of units shipped from origin I to destination j. So I will be 1 2 1 2 and 3, and destination in our case it will be 1 2 3 and 4. So in short, if you want to show the uh, variables on the diagram, from one destination to one origin to one destination, it will be, number of units will be x11. So I am just writing, showing here x11. From 1 to 2 it will be x12 here, like this. So you can capture them here if you want, for quickly. For from here to here it will be x35, right? So difficult because I am using the pen from this computer, but if you are doing it on a paper, it can do it very fast. So this clearly helps you to really put all the information on one diagram, and then we can set up the model. So obviously, in whenever such problem is there, the objective of the problem is always and always to minimize the total transportation cost, and the obviously the cost will be obtained by the per unit transportation cost, which is 3, and the number of units transferred on that route. So from 1 to 1, the total cost will be 3 into x11, because x11 are the number of units transferred from origin 1 to distribution center 1. So similarly, 3x11, 2x12, 7x13, 6x14 will be the cost, plus x 7x21, like this, 5x22, like this. So if you look at the equations, the obviously, let me just directly take you to the, so this is our objective function where all these are added, uh, the per unit cost into number of units transferred, all. So this is the total cost which we want to minimize. Now subject to constraint. So if you go back here, what are the constraints? Obviously whatever is going out of this plant cannot exceed 5000, because 5000 is the capacity. So we can write x11, x12. We don't have to multiply now, because we are not talking about the cost, we are talking about the units which are produced and units which are transferred or transported. So x11 plus x12 plus x13 plus x14 cannot exceed 5000. So that is how you will write the distribution, the origin constraints. This less than 5000, for second one less than 6500, for third one less than 2500. Now about the distribution centers, we can write like whatever is coming in the distribution center should be sufficient to meet the requirement. So x11, x21 and x31 all are coming to this Boston. So this three together should be equal to 6000. Now the point you should remember is that here we will always use equal to sign. Why equal to sign? Because distribution center uh, is like place where the things are kept under a warehouse, for example. So if you send more, there will be no place available to store that material. Maybe your material will remain on the road and it may get spoiled. So that you cannot send more than the requirement, and obviously you should not send less than the requirement, otherwise the customers will suffer, because the customers will get the material from distribution center, and distribution center itself has a shortage because you have sent less. So here on uh, the demand side, we will have to always use equal to sign. Our model should be able to give exactly the required demand. And lastly, we will always have these non-negative integers. All my variables should be positive, so xij should be greater than equal to 0. So when you set up this and solve in your solver, you will get this answer. These are the various, and the total objective value, or that means total cost, transportation cost, the minimum one can be achieved is 39,500, and this is how we are going to send the number of units on those routes, right? So if you see here, this is the final answer. The units shipped from Cleveland to Boston is 3500, and this is how you write your final answer. So this is the transportation cost. There are problem variations which the book clearly explains, very easy, so you can refer to those and understand the variations as well. After this, now we will move to transshipment in my next video. Thank you.